Before we get into it, I like to invite you basically if you go to the workshop section of my website and then go to React and go plugin workshop. Well, I'm recording it at the moment, but then you will see the files and the repository will show up here so you can download the code and follow along. Now, in this course, I'm not going to type every code because I assume that people watching this are already having a good experience in the React, JavaScript, Golang, backend, in general, like some hands-on experience. Therefore, I'm not gonna go and type in everything. I have prepared the project as like code base that you can just clone and then follow along. And in this workshop, I'm gonna explain what has happened and we will move on from there. So, what is a modular system? A modular system is anything which allows multiple parts to build a product from multiple smaller products. The term is very wide, but a lot of times when we are talking about modular system is usually we are talking about 10 different folders, 10 different smaller projects are being glued together by a host and becoming a final product. Now, I see a lot of benefit in this having like multiple different modules and placing them into a repository and create a product out of it, especially if we are creating multiple product out of it. Think about of an accounting software which has like 100 different possible modules, and 50 of them might make a specific use case and the other 40 of them which might even overlap are creating another product. So from 100 modules, you might be able to create 20 different products, and a modular system helps this like pretty much and perfectly to achieve the goal. So a modular system can be very wide, but I want to highlight a few interesting ones. One is microservices. So microservices is basically when a part of a system, a part of a product, or even a part of a brand is divided between multiple people, and like the processes are like done a little bit uh, excluded from each other. Assume that like there is an invoicing microservice, invoicing department, and just a second, and another like product department. So when a product is being sold, you will tell the invoicing department to issue an invoice. Now, what and how the invoicing department or invoicing microservice is going to issue the invoice is not deal with the product team or product department. Rather, it's just internal information which has been excluded from each other. Now, this brings a lot of benefits. For example, if the invoicing is a very complicated thing, like you're selling worldwide, so why the product information has to know about that, and then people and this product and software can be focused on the invoicing, and the other team can be very focused on the product. So another modular system is micro frontends. So it could be done in many facts, many different ways. One of them is to like module federate them using Webpack or White, and then you can put like bunch of folders, bunch of sub projects, or even a monorepo. These packages, install them into another host, and then you create a micro frontend. Now you can glue an Angular and React together, even like half of it is React, half of it is Angular. It's just possible. It's not, I don't mean it's a good thing to do, but it's possible. Another way to do that is a multi-project with a central routing. So you create multiple projects, but another router in between just says a slash products goes to this endpoint internally, and then slash whatever, like user goes to another section. The thing we're going to discuss in this workshop is a serious plugin system. So a plugin system is a modular system, but they're a bit different from the others. It doesn't collide with them. It can coexist with them, but it's very, very different mindset and different way of implementing things. Before we move on, we need to understand the environment we're creating a plugin for. Now we are creating a product. Obviously, it's going to run inside an environment, and that environment is very important to be understood beforehand creating a plugin system. For example, when creating a system service, a backend like an HTTP server, most of the time, is that we understand, okay, how the file system works there, what we can include, like is it the scripting language, is it the compile language, and then in the front end, we have to know what is our limit, like what can be done via CSS, what can be done via the JavaScript, how much we are limited, what is our other options, like can we put just an iframe and call it a day, WebAssembly is going to help us, or just we can put JavaScript in it or glue markup into the app. Obviously, same goes for mobile apps like Kotlin and Swift. It's very important to know like those two technologies are coming with a very comprehensive plugin system already. So you're going to create a plugin system on top of that, which is going to be much faster, easier, better, like more standard in every possible imagination. So before I create any kind of plugin system, I really do research if I don't know the environment. Even if you do know, it's a good idea to do it because things change over time. Before creating a plugin system, you need to be aware of one important thing. 99% of the time, you don't need any microservice, micro frontend at all. It's just 90% of the projects I have worked on, they never needed a micro frontend microservice. Like they had all the code inside the same repository and it could be working like as a standard project. Much easier, much faster, lesser bugs. And the same goes for the microservices. It sounds a little bit cool at first that you are splitting the tasks and everybody can focus on the other thing, but then like you want to just create a report, like you basically lost the same database. Often people just use the other database there and you cannot even have a left join. And it's a very long discussion by itself. I don't want to enter that because the goal of the workshop is to plug in, but think of it, you don't need this. It's a bit counterintuitive because I'm talking about this topic and creating workshop and I'm saying it's not needed, but it's a bit of reality. The business requirements are usually that the app, even though like has like tens of millions of people using it, the process is fairly simple. It's just facilitating the one process. Not everybody's writing AutoCAD, and that's what it is. So you might really think if you really need this. It has a lot of details, so we're gonna start easy, but having a very good plugin system means you have to expose a lot of things from the host. You need to make a good channel to connect between the plugins, even though they don't know each other exist. So all of those things are complicated over time, and then like one thing leads to another thing, and then you just see yourself, instead of building the business requirement, building the app which generates money, you're just creating a plugin system like endlessly. Monorepo is also often complicated, not much return out of it, especially if you already know what that is, or like 5 to 10 people are working on the code base with a good relationship between people. It's very easy to mitigate the requirement that like we have to go and install and continuously release that. Just adds a process which brings no value at all. Module federation is also, I think, not very great idea. It's a little bit against the plugin system, but I might be able to wrong here. You need to check it yourself. But module federation invite, at least what I saw is that you have to create the project and then put it inside your source folder. So it's a compile time thing. So when you're building your host app, you're just collecting those things. This is not what we want. We want that our app is built, completely created, and then people go create plugins and they drop into the existing app without changing the source code, and the plugin starts to work. That's the real value of that. So you want that plugin system be written by other people you don't know. Creating a host plugin needs strong API. As I mentioned, you have to keep like the contract very healthy and versioned correctly, and it's really hassle to like say, okay, my host app version 2.5 to 1, for example, has these APIs, and then like one version bump and then added to these things, or this signature has been changed. So like then you have to say plugin works with which version of the host, the range, not like the packages inside of that. Though it sounds a bit complicated, it's doable, but if not brings you any money or value, then why you want to do that? The general point is be careful with this direction. It's just too much work. So, in the other hand, when you need the plugin system, there is a scenario that you need a plugin system, and a system which is developed outside of the main team. So you're creating a product, and it will be developed by extended by teams that you even don't know. Like, for example, AutoCAD team, they're creating a product. They don't know a team somewhere in Singapore is requiring some special operation. They write a plugin, add it to it, and then they continue. Like, or look at the Blender. Tons of plugins has been written that Blender developers didn't know. They just provided the plugin system. Other people created that and extended the functionality. So for such softwares, for such scenarios, for example, SAP, those kind of portal, or Salesforce, they need a plugin system, like a massive plugin system. Their plugin system even goes up to the level they provide a language, programming language to it. So it's very important that know that these scenarios actually need a plugin system. So without plugin system, they would fail. Another reason is no way to anticipate what plugins will offer. So you don't know like what extension needs to be done to your system, basically, and other people might come with better ideas. Therefore, you introduce a plugin system. Massively modifiable requirements based on region laws or more. So let's say you created e-commerce system which works in Germany, and then you want to make it work in Sweden as well. So if you create some plugin system which Swedish people can introduce their own purchasing system, the laws, the taxes, or whatever it is, age restrictions, then basically you can like improve that without touching the main code base all the time. And lastly, you have determined that there is no other way, like you have to create this, and you achieved it in your team or your mind that it's a requirement, so you go and create it. So a plugin system is when a plugin extends a system or able to modify the existing features. So it's very important that a plugin shouldn't be only that you just add new screens or add new features, but rather existing features in the system can be modified because of a plugin. Especially if another plugin is in the system, you need to consider that that plugin might affect the other plugin. So all of these are like important to consider. A lot of products are doing it successfully. I mentioned already a couple of them. So it's not impossible. Like WordPress is doing that perfectly. Like the plugin system, without the plugin system, WordPress is basically nothing. And you install few plugins and just uplifts the system very fast. You need to provide a lot of hooks and details to most operations. So here I like to be able to highlight and explain more. Assume you have a sign-in page and then you want to create a plugin. You have to consider in your sign-in page that when I click on an element, there is a hook, like that element got focused. When I start typing in, there is a hook that something is started typing. When I want to press the button before submission happens, there should be a hook that this form is going to be submitted. So if I want as a plugin to modify the values, I should be able to. When the response comes from the backend, for example, sign-in process, there should be another hook that the plugin can take it and then modify the response before going further. It should give me the option to redirect. It should give me the option to show an error message. So you need to provide a lot of details for a very simple screen in order to make it pluginable. So this is something mostly you can't adjust in terms of a business need, that you need all these things to be modifiable. And then when I come to write the plugin for your system, I should have access to those things, because even if you give me 100 details, believe me, there will be another 50 that you haven't thought of it, and if you start with very minimal thing, it's just not good. Like people can't really write plugins that much. And then you have to give obviously as much as freedom possible to the plugin writer. So options we have in the browser is one, we server render it all. So instead of having an SPA and then like a React or whatever it is, just have a backend MVC process which takes every route, and then the plugin system works there and then modifies the HTML coming down to the browser. So that's why you see a lot of the e-commerce platforms like Magento and then PrestaShop, I don't know, WordPress, SAP, all those things are not SPA because it's much easier for them to apply all those rules and then print the markup in the server and then show it to you in the end than going through that and then like creating APIs, which in the front end comes and then decides which one to show or which one not to show. And then that's why also you see like Google, all those major services are not SPA. They are just like traditional JSP pages. And it's very powerful. So another option we have is include the module in JS bundle, such as module federations, as we discussed a little bit earlier, that you just pick up a module, put it inside the project, you build it with the app. It's not really plugin system anyway, because you already knew what you're including in your build. So how is this a plugin system? But in the end, you can say it is a plugin after all. Include JS files globally. That's what we're going to do in this workshop, that we just take any random JS file and we don't know in the compile time about it and we will use it. And then we can use also WebAssembly. It's a little limited, but it's a very good plugin system. For example, if you don't know about the WebAssembly, think of it this way. It's a file with like a lot of functions in it you can write. Let's say 1,000 functions inside of that, and then those functions are being exposed to the JavaScript. So you will say my WebAssembly dot calculate one, send some arguments. Function is calculated in WebAssembly, like you have written it in C or Go, in Rust, even JavaScript itself. And basically, yeah, that's like going to return you a response and you will use it in the browser anyway. But it's a sandbox. You can't really use that in a way that like directly manipulating DOM elements. You need to expose functions between them. And it's a lot of discussion itself. Maybe another video about that. Options we have in Golang or generally in backend is either we create a system call, so we can say a syscall to a Python script. Then we give the user a dashboard and they will write a Python script or a Lua code, and then we will execute it in the backend. With the Python script or system call, it's a bit dangerous because you don't know what they can include, and they can just include whatever they want, and it's very hard to audit that, and like the whole system crashes or something. With the Lua, it's a little bit better because it's sandboxed, and it's very similar to WebAssembly, and which we'll do in this course. Though options are a bit limited, especially in the Golang, because it's a compiled language. So there is a plugin system built into the Golang, but only works in a specific Linux type. And it's very conditioned. It's not guaranteed it's going to work. So our options are a little more limited, but it doesn't mean they are not powerful. Node.js is the same story because the server renders all. We can do that. We can include the modules via import require, though because it is a JavaScript in the end, a scripting language, you can just create a folder and then put an index to it and then write a lot of logic, and you can say go and load the JavaScript from this folder, and then you introduce the hook system and registry module to it. But it is not really safe. It's really like similar to the level that you can have in syscall basically, and it's going to be very challenging when you want to give the plugin system tenant based. So if the tenant has to install a plugin for them and the other tenant not, then really this can go out of hand and not possible in practical. reasons. And WebAssembly is still an option in Node.js. That's a perfect thing. So that's what I like about writing a plugin in WebAssembly. You can write it in C or Go, and then it works basically everywhere. A lot of libraries, for example, I saw this email template module, which now available in Go, while WebAssembly, if they have written a lot of calculating things, like this mail template, I forgot the name at the moment, but it would be running in basically everywhere. And that's super cool. Like you can't write the Go code, it runs in JavaScript, it's harder. With assembly, no signing required, nothing, and it's relatively fast. Another topic is the sandboxing. The sandboxing is very important. Sandboxing, as I implied so far, we need a sandbox for plugins. We don't want plugins access to the file system like network. We don't want them to have access on the front end to the microphone or anything. We want that they can only request what is given to them, and the host system can manages all that permissions. You see now it gets more complicated, right? So, for example, you want to give the plugin access only to 2 URLs that they can communicate with, not the third one. Similar to the Android manifest, if you look through it clearly, it's like you're telling what permissions is allowed to this project, because Android and APK files are also very sandboxed, and that's what you want for the plugin system. Of course, syscall and all those things integrated are not providing that. We have to predict what is accessible to the plugin, and we need to like know the plugin can access a microphone or video camera or whatsoever. Now in the JavaScript, gonna be a little hard to do that. We need to shake the code. We need to parse the code in AST mode and then check if there is such function calls to etc fetch. But it's a necessity to be done if you want to have a very correct plugin. You might need to scan the code actually in JavaScript. The WebAssembly, on the other hand, provides very significant security by sandboxing. So that's very way to go. Now, in the next chapter, we're gonna go and create the front-end plugin. We're gonna discuss how we created the plugin. We're gonna discuss the host API and all of those details in practice. So be with me. Thank you for watching to this moment, and I promise you the practical part starts right in chapter 2.